Let's next talk about polynomials. Polynomials are sums of terms, and the terms need to satisfy some rules. In the terms we might have one or multiple variables. The variables can be put into some natural number powers, and they can be multiplied together, and we can multiply each term with some constant. So for example, we could take the variable x and put it to power 7, and we could take y to power 3, and we could multiply these factors together and still multiply them with some constant, and this kind of term would be okay. Also, another term, x to power 2 times y times, let's say, z, this term would be okay, and the sum of these terms, it's a polynomial. The variables in this polynomial are x, y, and z, and a very useful notion is the notion of a degree. We look for the highest total power. Well, the power of x here would be 7 and the power of y is 3, so together these powers would make up 10. Here the powers of y and z are 1s, and together these powers would make up to 4. Well, 10 is larger than 4, so this polynomial has degree 10. Let's next talk about polynomials with one variable. The degree of this polynomial is 1. The degree of this polynomial is 2. And the degree of this polynomial is 3. This expression is very useful in physics if you have some motion with constant acceleration. This formula would tell the position of the particle at time t. This expression is also a polynomial, degree 2 polynomial of variable t. Here these other letters a, v0 and x0, these are considered here to be constants. The main interest is for us that when time goes forward, where will the particle go? Let's consider the calculation rules of polynomials a little bit. Let's remember that when we open the brackets, we remember to multiply all the numbers with the thing in the front. Here we would have -1, so we would multiply all of the terms with -1. It seems that these terms cancel out, and these terms make together 3x, so we would get something like this. If we have a product, then we need to remember to multiply all the things in the other factor. So here we would get, let's see, x times x squared is x to power 3, x times -1 gives -x, 3 times x squared gives plus 3x squared, and 3 times -1 gives -3. And we cannot simplify anymore. Well, maybe it is nice to put the terms in the order of the powers. Now the powers of x are here nicely in order. That looks nice. If we want to simplify a plus b squared, we can use the definition of the power to write it as a plus b times a plus b, and now making the calculations we would get a times a is a squared, a times b is ab, b times a is ba, and b times b is b squared, and because ba is the same thing as ab, we see that there are two ab's here. So we will get this kind of nice rule. A nice rule like this. Well, how about a minus b squared? We could calculate it in the same way. That would be fine. But on the other hand, if we would put here in the place of b minus b, what would happen? Well, we would get minus 2ab because there is just one minus sign, and on the other hand minus b squared is b squared, so we would just get b squared. We got another calculation rule. The next rule would be the difference of squares. So if we have a minus b times a plus b, you can check the details, but if we calculate what this gives, it gives a squared minus b squared. Let's use these formulas for polynomials. If you would have to simplify x plus 1 to power 2, we could use this formula here, and we would get x squared plus 2 times x times 1, well, that's 2x, and 1 squared, which is 1. On the other hand, if we would take x minus 1, let's say minus 2 times x plus 2, we would get a difference of squares. We would get x squared minus 2 squared based on this rule here. If the thing what we are calculating is not so nice, maybe it looks a little bit complicated, then we wouldn't have any specific formula for this. We would just have to work it out. X squared times x is x to power 3, and x squared times minus 2 gives minus 2x squared. Then we get 1 times x is x, and 1 times minus 2 is minus 2.